Okay guys, I'm just going to go through the next few exercises, the one that we did in the prac yesterday. So this is for map exercises 6 to 8. I'm going to do a similar thing to what I did last time and just go through these one at a time. So this was exercise 6. This was the first of the maps that we did yesterday, and really the main complication within this one is that there is this fault running down like this. So this is causing offset of these units on the left and right hand side of the map. The rest of the units are dipping at 17 degrees. I guess one of the main things that I found confused students in the internal practical yesterday was what to do with the units that had no strikes and dips on them. It's pretty common when you're looking at geological maps to find units that have no strikes and dips on them, and that's because it can be very difficult to measure strikes and dips on certain rock types. And so these ones that have no strikes and dips on it simply indicate that the geologist who was mapping in this area couldn't find a good bedding plane to actually get a measurement on. So in this case we have to infer what the bedding is doing based on the context of the rocks around it. And as you can see, all the rocks that have strikes and dips labelled on it are all dipping in the same direction at 17 degrees. So it's very fair to assume that this rock unit, which has no strikes and dips on it, is also going to be bedding at 17 degrees. So here also 17 degrees, and same with these guys up here, they're also going to be going at 17 degrees. So just because there's no strikes and dips doesn't mean you can't infer it from the context of the rocks around it. The other complication was what to do with the strike and dip of the fault. Now there's no strike and dip labelled on the fault, so in this case we'll generally just assume that it's going straight down, so it is a vertical fault. You can measure strikes and dips on faults, but in this case there is none, so either it couldn't be measured or it was already it was a vertical fault. So that's what we're going to go with, and that's going to be our assumption. So here is the cross section that I drew. Again, these are really quite rough sorts of cross sections. I expect you to try and keep yours as neat as possible. And all these units are dipping down at 17 degrees towards A. So here we have, once again, our A and A prime. Students yesterday asked me how they knew how high this was. We don't, because I didn't actually put any label of how high the topography was. But for this example, I've just drawn it as 400 meters. Feel free to make up any sensible measurement that you want. So just keep it reasonable. 400 seems like a reasonable number to me. All the other flat topography ones we did were at 450 meters. So if you want to keep it consistent, that could be a good number to choose. The topography itself is labeled as flat, so there's no contours on here. So again, topographic profile, first thing that we draw on there, nice flat line across like this. Try and keep it as level as possible. Then of course you go along and put your tick marks for each of those different geological units, which were these ones here along the surface, and you draw those down at 17 degrees. So once again, that angle in there is 17, 17, and so on and so forth. So we draw our lines down at 17 degrees like that. Now I guess the next difficult thing to figure out in this map is what to do with this material down here. How do we know how thick those are? Well, there's a couple of ways we can figure out how thick they are. Firstly, we've drawn our vertical fault in, and we've got our units on this side of the map. Now those units are always going to stop at that fault, just like they do up on the map. If you look here, here's our fault here, and of course our units come down and stop at that fault, and then they start again at a different place on the other side of the fault. So they will always stop at that fault. So we have them stopping at that fault like that. Now the thing is, the units on this side of the cross section, and on this side, the units are going to have the same true thickness underground. So we can measure off the ones that we've drawn in on this side. So if I want to know how thick, say for instance this unit is here, if I want to know how thick that's going to go down, I can measure it off from this side of the cross section, measure that there, and it's going to be the same thickness on this side of the map. Measure the thickness of this unit, the true thickness, and it's going to be that same thickness here. Now obviously I haven't drawn it particularly well. I just drew this as a quick draft so you can get an idea of how to do these. I'd expect you to try and keep yours a little bit more consistent. And this guy here is going to be the same thickness as this one here. And again, we've got an area in here that we don't know. There's no information we've got because that's off the edge of our map. So we don't know if this unit continues this way or if there's another unit that starts, say, there. So I've just put question marks down in that part of the map. Now, so this, using the thickness, that's one way that we could figure out where the units were. The other way we could do it is simply extrapolate these up like this. And this is actually what I did. This is really the cheating way of doing it. And again, when you have your piece of paper lined up across your map like that, you can now put your marks on there, there, and there. And that's exactly what I've done. You can see these little tick marks I've done here because I haven't neatened it up. So these ones underneath there, I basically put tick marks there, and then I drew lines down at 17 degrees, something like that. But again, I didn't include the part up here. I only started it when I got to that fold. So I started them from there. So that's one way. That's the other way of doing that. That's probably the simpler way of doing it. So hopefully exercise 6 all makes sense to you now. I'm just going to stop the video and start again with exercise 7.